questions before that final exam starts tomorrow. Okay, would that help if I came in after you get prepared and you stop by room 63 there? Okay, I said, I'll try my best to get here. That's not my day to be here. But I'll try to be here at 11:30 tomorrow. Answer the last few questions. Okay, Arena, you're going to be my big helper tonight. So you're going to help me. Okay. Okay, guys, let's do this. The induction proof. Gia, I'm not going to hold you responsible for it on the test. So that's one item you can clear your mind of. How can I show a statement is true for all integers? It's a good process. You've seen enough, I think, with what I did yesterday, and I gave you a handout. But no. I'm not going to hold you responsible for doing an induction proof on the exam tomorrow. So that's one thing you just not worry about. We did one yesterday and worked out fairly nicely, and the other one went crazy on us. Like we did not quite finish it up. Okay. Mr. Park, June mentioned that maybe she did see an induction, some type of induction in one of the classes, right? Yeah. Okay, so at least my students moving into a calc class or whatever class, if they mention induction, you say, oh yeah, Ramsey shows the essence of what an induction proof is. How to prove a statement is true for all positive integers. And I think the one that worked out nicely for us yesterday was a good example of what induction is all about. Now, binomial theorem. Now, you know you're going to be testing on that. Now, I got to jump back into it. Please, someone wants to tell me what we concluded with. And I think it was actually the binomial theorem and what the theorem looks like with that summation notation and how to write that out, what it means. And I'll close that down and then show you the sketches I need to show you. And I'm going to have a big piece of time, thank goodness, for review. Okay, so let's do this, guys. Called the binomial theorem. I think I started out with Pascal's triangle first. Did I? We had a lesson on Pascal's triangle. You guys were with me. And then moved there into this binomial theorem. Can anyone tell me, there's a summation notation. We don't know what that means. It means a sum. If we start out with a j is equal to 0 at the base, in the theorem itself, was there a j here? Does anyone recall what the top of the summation notation was? N, thank you. Inside there, it's strange, but we discussed this yesterday. Was there an N choose J notation? Now, what variables did I use for the other parts? Remind me, what goes here? No. A. Well, I think I called it A, did I? Was it A?
The first was x to the n minus
Oh, let's
j,
call it
and
x
then
then.
a to the j.
Okay, let's call it X. Raised to the n minus j. And what did I use for the next part?
A to the j.
Okay, a to the j.
A raised to j.
And we use an a there, right?
Yes.
Okay. It look like that? Now, if I walked in and I saw that on the board and I was just a beginning math student, I'd say, what on earth does that mean? How can I translate and show you that this actually takes me back to Pascal's triangle and a binomial expansion? I think when we were leaving yesterday, I asked, suppose you saw this. I'll make a connection here right quickly. J is equal to 0, I think I went through 2 here. And since n is 2, this would be written as 2 choose j. And then x raised to the 2 minus j. And then over here we had a raised to j. I think I replaced this with a y for my example, which you could. Y raised to the j. With you guys? So you see that staring at you and say, what does that mean? I think we went through it. It means something for middle school. But the middle school kids don't see it like that. So guys, all this represents, I'm going to verify it with you, represents, and you guys can remind me, we finally concluded this is the same as, I think it was what, x plus y squared? Was it equivalent to that? And that's middle school. X squared plus 2xy plus y squared. But you guys show me why. Why on earth is this strange statement called binomial theorem equivalent to this, which could be picked up from Pascal's triangle? Why? I may ask you, probably will ask you, to write a few of the terms out for me. In fact, this one's short, so I'm going to write all the terms out. Now what does it say to do? It starts at the base with 0. So it's 2, choose 0. X raised to the 2 minus 0. Y raised to the 0. I'll replace j by 0. Then go up to 1, now replace j by 1. Then that looks like this. 2 choose 1. X raised to the 2 minus 1. Y to the 1. And then finally I've reached the top, where they tell me to stop, that's 2. Let's put a 2 in there. So now it's 2, choose 2 with a j. X raised to the 2, subtract 2, and y to the second. Is that the way it looks? If you actually tell me what the summation in the binomial theorem they call it, is that it? That's what it looks like. Now if you expand this out, you have to know the little formula here. And I think I gave it to you yesterday. N choose J. I call it N choose J.
Yes.
And again, June did a beautiful job in her notes on all this. Guys, what was it? M factorial? I think it's a formula. Was it J factorial? And N minus J factorial, yes or no? Try to apply that to each one of these to see what on earth is this representing 2, choose 0. Guys, let's try choose 0 on the side here using that formula. And it would be 2 factorial over 0 factorial over 2 minus 0 factorial. 2 factorial, 2 times 1. 0 factorial by definition is always what? Who remembers? It's not 0, it looks like it should be 0. It's 1 by definition. Can't change it. And of course this is 2 again. Guys, I think I end up with what here? 1? Okay. So that means I'm going to start out with all this right here. 2 choose 0. I'll walk up to you in the hallway and say, what's 2 choose 0? You say, Professor, please. And what should it be equivalent to if there's no mistake? Should it be equivalent to 1? So this says on the first term, now it becomes, and I'm running out of space here. I'm all over the board here. I don't want to do that. So I keep organized. That means that first term now is 1, x squared, and y to the 0, of course, is that another 1. So all that just says merely the first term is this, 1x squared. All this is just x squared, 1x squared. Now the second term, this one, I need 2 choose 1. So on the side, same formula, 2 factorial over 1 factorial over 2 subtract 1 factorial. Guys, if I look at it closely, do not let me make a mistake here. Of course, this is 2 times 1, if you want to expand that out by factorials. And down here, 1 factorial, not interesting, 1 factorial again, just a 1. Do I finally end up with a 2 when I calculate this? So that means that now I'm in the middle term. So 2 choose 1 come out to be a 2. That's done. X to the first and y to the first. That's my second term. Done. Third term, last term, 2 choose 2. It's not going to be too exciting, but here's what we do. It's 2 factorial over 2 factorial, 2 subtract 2 factorial. And guys, I think here 2 factorial, we've seen this many times, this is merely 2. This is 2. This becomes a 0 factorial, which is 1. And I think I end up with a 1 altogether, 2 over 2. And what was that on the end here? Got a 1 here. I don't need to put it in. X to the 0, another 1. Y squared is the only thing left on the third term. Please tell me, did I do the calculation correctly? So have you shown that this crazy thing here, look how crazy this looks, is equivalent to this? Or better yet, equivalent to, as we said earlier, this, a binomial square. Now, please tell me on the exam tomorrow, if I give you just this, I'm not going to get too much in detail on this, but if I gave this to you with some numbers in here, could you write out a few of the terms for me? Like I did here. That's what I'm looking for. Can you actually make sense of this crazy thing and write out a few of the terms? Okay. Guys, any concerns with that? Binomial theorem? That's all I want to do is binomial theorem. I'm finished. Okay? Not going into much detail there. That's all we need to know. Now, to close down class, I can't believe this. Close down the course. And I'm going to be busy. You're going to be busy just reviewing for the test here shortly. The last part of the course is, can you recognize, now, sketches that we have seen before. I give you a handout. I think it's on the same handout with the binomial theorem. Arena, check on the back there. Did I mention something called the conics? Okay, now I don't have a cone here with me. Usually I bring the cone in and start slicing it up. It's called the conics. Call this part 2. And guys, all it is sections of a cone. And like I said, I don't have the cone here, just stand here with you and try to slice it. You know what a cone looks like. And then they ask us to slice it and come up with slices, and they give a name for each slice. Okay? And they name each one with a vocabulary word there. I'm going to first mention arena. Did I mention the first slice might be a what? Circle maybe? Yeah. Okay. It all depends on how you slice that cone. Another slice could be parabola. You've seen that sketch before. Could be what? Ellipse. And could be, the last one is? That's one of those little strings, but we'll see what it looks like. A hyperbola. Okay. Now, before I get into it and close it down, show you exactly what I would expect you to know. Not too much on this, guys. I feel a little awkward not having that cone with me. They've already packed it up and sent it over to the new building. That's why I don't have it. We know what a cone looks like. I don't know how well mine's going to look when I sketch it. Let's say you have something like this. And let's make it look like this. We'll accept it as a cone. I think that word problem we had back not too long ago about if we had a cone involved in a word problem, but the cone was what, inverted, and we were pouring water into what, the top? It was upside down. Here's the cone's sitting in a different position here. All they're asking us to do is slice it. You say, Professor, what do you mean slice it? Take what they call a plane, a sheet of paper, flat surface, and maybe take it right through like this and slice it. You've got to keep in mind, guys, this is a solid. Slice it, take it through the board there, and slice a piece off. And since it is a solid, you may end up with a slice that might look something like that. It depends on how you slice it. And of course, that's an oval shaped sketch, which we have not dealt with in this class. And it's given the name ellipse. It could be the way you slice it. It could come out to be actually a circle rather than the oval. It all depends on where you slice it and how you slice it. So guys, under the slices, oh, by the way, the parabola, it's going to be awkward as, I don't know what I can do with that parabola. We know what a parabola looks like, of course. And then this one's even more awkward. But that's what we're doing. We're slicing the cone up and naming the slices. And each one of these slices has an equation. Okay? Now we step back and look at it. Here we go. Let's see if I'm ready for circle, all I'm gonna say about a circle is, does anyone recall the standard equation for a circle? A circle that has a center and a radius, that could be one of these slices. Does anyone remember a standard equation, even before you met me for MATH2, that might be appropriate for a circle? Yes, go for it.
2 pi r.
Oh, that's 2 pi r, that's the circumference.
Okay.
I want the equation, like if I ask you what's the equation of a parabola, you may say, Professor, are you talking about ax squared plus bx plus c? Now, how about an equation for a circle, does anyone recall?
Pi r squared.
So again,
Pi r squared.
not quite,
2 pi r.
not quite. I think you forgot, I bet you've seen it, you forgot. What they consider the standard equation for a circle. And a circle has what, a radius and a center. Most textbooks will write like this. X subtract h squared plus y subtract k squared equals radius squared. Where they're assuming in that standard form that the center of the circle has coordinates hk. And the r, of course, is radius. So x subtract h squared plus y subtract k squared equals r squared. And I know you're thinking right now, Randy, we're gonna be nuts by the time we leave this class. We've covered so much of this 6 weeks. Can you imagine? You've done 16 weeks of work in 6. So you should be very proud of yourselves. I've got through all this. Parabola, now I've asked you to give me what you think of right now that could act at this point as an equation for a parabola. Most students give me something that I think you should be able to give me. What would you say, Professor, why not use this for the equation? What is it?
X squared.
Oh, good, just a basic. That question into a parabola. If you want to get a little bit more involved here, you can say, well, Professor, quadratic, that may look like this. You know, that would also graph into a parabola. And this one may be asking on the test tomorrow what the maximum is. Remember that negative b over 2a business we did? You guys had a lot of review to do. That negative b over 2a, and you try to find the max or the min of something that we dealt with. We did those. You may say that's it. Well, it just so happens there's another one that you have not seen for a parabola. We'll get into that here shortly. Ellipse, I doubt. Let me throw it out there. Does anyone think they know what the standard equation, guaranteed, if you graph from that equation, you get that oval shape. You get egg-shaped, oval-shaped ellipse. Does anyone think you know it?
Would be the same as circle,
No circle. No, you can't use the same one for a circle. You may want to go back and try to modify it a little bit. No, it's a little bit different. And you may not have seen it.
but divided by 2.
There's a fraction involved. I'll show you what it looks like. X squared over a squared plus y squared over b squared is equal to 1. And you have different versions of that. I'm going to stick with the most basic since we're closing out class. So if it looks like that, if you make your equation and take that form, you're guaranteed when you go to a sheet of graphic paper or a grid and graph it, you're going to get an oval. You're going to get an ellipse. Hyperbola, a little different. I'll take questions here. It's x squared over a squared, subtract y squared over b squared is equal to 1. It has a subtraction sign. And it graphs into something you have never seen, I doubt. What on earth does a so-called hyperbola, Professor, look like? You've already told me the ellipse is egg-shaped, oval-shaped. I can accept that. I know myself, Professor, from elementary school what a circle is. And we did parabolas. I know what the shape there is. This one is a strange shape when I graph it. We'll graph like this. Now guys, we keep this very basic. talking to one of my colleagues, and all he did, he sent out a video on the conics. He didn't discuss it at all in class. He just sent his class out a video. No. We need to go a little bit more. Okay, guys, we step to the side there. I think I saw a hand going up though from someone. Before I jump into it and do it here. Okay. Arena. I'm not going to do much with this, but I am going to do this much. Did I give a definition for a parabola? You said, Professor, please. We've spent some time on parabolas. I know what a parabola is. No, you don't. You know the shape of a parabola. That's what you know. So you go over to UCLA and USC, and you sit in that auditorium, and all of a sudden the professor says, what is a parabola? And you volunteer, and you come from SMC, and you say, oh, that's a parabola. That's the graph, that's the sketch. That's not what a parabola is. That was the definition of a parabola. And I doubt if many of us in this class have seen the definition. UCLA's going to say, where'd you come from? SMC. Who's your instructor? Oh, don't mention my name. Oh, don't mention my name out there. Sorry, don't mention my name after you leave. No. But this is a sketch. That's all you know about a parabola right now. Now we'll just do it for one of these conics. There's 4 of these. I have time to just do one. We'll do the parabola, the definition. We'll do a good job on it. And see if we're on Earth, the equation that I'm looking for came from for a parabola. And guys, these are quadratics. A quadratic will graph into a parabola. I want to know the true equation for a parabola. It's not up here yet. I have quadratics, but the true equation for a parabola is not on the board. We've got to derive it. Okay, Rena, could you read, and this is the only one I'll do, I want to show you a quick sketch of the others. Could you tell me what on earth was the definition, and I will mark things as you do it, for a parabola?
A parabola is the set of all points in the plane equidistant from fixed point, focus, and the fixed line directrix.
Oh. Hang on. Let's go to a grid. So now if you go over to Stanford, or USC, or UCLA, Dartmouth, NYU, and they ask you now what is a definition for a parabola, you'll know. You know this, not just that sketch. Now, Karina, my helper today, read that to me one more time, and I'll stop you at various places, and I'm going to start placing things in the grid here.
Parabola is the set of all points in the plane equidistant from a fixed point, focus, and the fixed line directrix.
Oh my goodness, so they're saying a parabola has more than a vertex. I think right now, all you guys know about a parabola more than likely is the vertex. Did we do the vertex earlier in here? Did we say, I think we didn't we? And we used negative b over 2a, and sometimes that vertex is the max, sometimes it's the min. We did a vertex, she's giving me other vocabulary. She says this thing also has a focus. Does that mean my class should be focused? Is that what that word focus means? No. There's another point on a parabola that you've never been aware of. It's called focus. And all of a sudden, as if that's not bad enough, she says, Professor, there's something else on this parabola that we've not worked with besides the vertex. What's the other thing called? A directrix. What? You didn't know parabolas that involved. Now, what happened here? I will place that focus point, as they're calling it, somewhere. I'm going to place it on the y-axis, just for convenience. I'll place right here. I'm going to label it as focus. You guys will label it as 0. I'm going to use C. The coordinates. Use anything you wish. We'll use a C. Now, we're going to draw the parabola that might be associated with this, and then we'll go from there. Guys, the parabola might look something like this. know the shape of a parabola. Now, she's telling me more detail on that definition. She says, wait, professor, that focus is gonna play a part. And then I think you used the word equidistant. Was another part of this called a what, directrix? And she says, Professor, that's a line. Watch what happens here. That says when we'll drop down to the same space, look at the space from here, that vertex up to here. We'll drop down on the other side, same space, equidistant, same distance, and draw a line down there. Talk about madness. But right here, over here, and call this the directrix. Joseph, who on earth would think that there's more to a parabola than what we're accustomed to? We got a focus and a directrix. We're going to make sure I have that spelling correct. Directrix. Philip, had you ever known there was more to a parabola than that? No, I would not have as a student. I'd be walking around so proud of myself just knowing the vertex. Whether it opens up or down. Whether it's a min or a max. I feel very proud of myself as a student myself, just knowing that. Now PK, there's no. There's more to it than that. You have a focus and you have a directrix. I try to keep these two equidistant guys as close as good here. Supposed to be the same distance. Now, here goes. Now close it down. She's telling me on that green parabola, any point on there, even the vertex, I'm gonna place a point out here. A point out here, I'm gonna label it as XY. That when I measure, and if it's not truly on that parabola, this should happen. Rena, I need to ask you to do this. Read it one more time to me, and then we'll do what I need to do.
Parabola is the set of all points in the plane equidistant from a fixed point in focus and a fixed line direction.
Okay, so they're saying, June, any point on that green parabola had better satisfy what she has read to me. And what she's read to me, she says, Professor, they're saying when you measure from that focus out to that point, you gotta do it like this, and then you measure from that point down to the directrix, something like this. If those two distances aren't the same, that point is not on that parabola. That point is not on that parabola unless it satisfies what she just read to me. So guys, from here to here, had better match up and be equal distance, same distance, as from here to here, down to that line. If not, it's not on the parabola. Who on earth would have known that? We did not know that until now. Now, by the way, I've got this point labeled as focus. I labeled it 0C. Does anyone have an idea what this point down here might be labeled as? And be careful. And by the way, it should be the same distance, guys. I use 0C. What might be appropriate to label this point down here as?
Y equals minus.
Well, it's the X for sure. Is the X coordinates staying the same? Oh, they line it vertically.
Minus.
What do you think might be appropriate to label that point as? The X for sure.
Negative C.
You think it's gonna be a negative C? Down here? What do you guys think? Is that sort of showing that this distance here is supposed to be equal to this distance here? Yes or no? Okay, so guys, we'll label this as y is equal to negative C out here. Okay? Now let's see what's going to happen here. Yeah, I think you're going to like this. By the way, can you imagine if I was going to do a derivation on the other, look at this, I'm doing this one right here, so I guess I'm not going to do this and this. In classes, previous semesters, I probably did.
Are they going to have this on the
Yeah, you have all this on the exam and more. Okay, now, I need the distance formula. She's talking about distance. Can anyone remind me what the distance formula was from way back? I'll get you started. How do you find the distance between 2 points? And that's what it comes down to. I need distance between 2 points here. Guys, anyone think they know what the distance formula is? And if so, I'll use it to express this distance, and we'll see what happens. Gina.
I have a question.
Go ahead.
So did we determine that it is negative C?
We did.
Okay.
Yeah.
We say that the distance between directrix and vertex is x. So from directrix to F, it means 2x.
Okay, let me ask you this, what you're saying, before I jump into and show you the distance formula that you guys have sort of forgotten. You see that vertex right there, turning point that we all are aware of? Phil, even on my rough sketch up here, does it look like it might be the same distance from that point there up to the focal point, focus, as it is down here? The vertex. And they're saying every point, not just the vertex, every point had better do that. So when you measure from here to here, you had better get the same distance as when you measure from here to here. Okay, now I want that distance expressed. Guys, let's call this, let me throw in some letters here. Let's call this point A. Let's call this point B. Let's express first, now here's the distance formula. It's x1 subtract x2 squared plus y1 subtract y2 squared. Probably the only class on campus who's seen this. I'm just doing the parabola, I'm doing all of them. There's your standard distance formula. Now, can someone look at that and tell me what might be the distance, what's called F to A, is equal to what? If I use that formula. And where the points are labeled like this. I'm here. What might this part right here look like? It says x1 subtract x2, or x2 might subtract x1. It says subtract the x's, this square. So what would be a nice way to express this from here to here for this part? Thank you, 0 minus x. I'm going to turn around and make it look a little bit better. X minus 0, same thing. Absolutely it is. And that is square. Now how about the y's? Y subtract, thank you. Now come back to that. Clean up a little bit. Now the other distance I'm concerned about is from A down to B. And guys, that, help me out, same distance formula, now you're going from here to here. Okay, help me out. X minus x, which drops out. So that's one thing I need not worry about. And tell me what the other part may look like. You got it, perfectly said. Okay, and I'll clean both those up. But this is distance 1, this is distance 2. And they're supposed to be what now again? What's that key word you use in that definition? What about those distances? What's that key word? Equidistant? They should be equal. Those two distances had better be equal. You guys, I need to set those equal to one another. There we go. Now on the side here, I'm about to clean this up. In other words, you're saying, Professor, you're going to do this. Says the distance is equal. The first one is merely square root, let me see, square root x squared plus y subtract c squared. That's the first one. That should be equal to, with PK's help, and this drops out. Where am I? We made it drop out. Yeah, square root of that y plus c. And was that being squared also, or not? Help me out, guys. Or is that just the distance right there, y subtract c?
Just.
Okay, beautiful. Is that the distance right there? Beautiful. You guys follow that? Now, if that's true, here we go. I'm supposed to set these two equal, which I have. Now you gotta clean that up and hope for the best. By the way, I see a square root here. Hang on a second here. On this, PK, when you said the distance from here to here, did you say it's merely, Professor, just y subtract a negative c?
Should be y plus the whole square.
Okay, was it x subtract x right here? Was that x subtract x?
The whole square is.
Was it from A to B?
Yeah.
Was it? And then was it, hang on, was it this? In fact, you told me correctly here earlier. It was this at first, plus then you call it what? Y plus C?
Y plus c the whole square.
The whole thing squared. Is that the distance formula being used on that? That true, guys? The x's subtracted from one another, cancels out, thank goodness eventually, then it is y plus c squared. Now, the reason what she did, she cleaned it up for me, this is 0. Now, what's the square root of y plus c squared, if you wish? Is that just merely y plus c over here? Which she's already cleaned it up for me, and I'm gonna do something else with it. You guys agree? This drops out. Another distance formula, the square root of y plus c squared is just merely y plus c. And that's what I think you were talking about. Okay, guys, I need to clean this up. Now, suggest to me, how would you clean this up? Square both sides. Oh, here goes. We're hoping. We're hoping things will work out for me. When I square the left, if everything's correct here, that's not too bad. That's x squared plus, square root's gone, by the way. I'm going to go ahead and expand the y subtract c. Y subtract c times y subtract c will give me what? Y squared minus 2yc or cy plus c squared. The other side, when I squared, I got to expand this out, is what? Y squared plus 2cy again plus c squared. Everyone agree? I square both sides to eliminate that square root. I hope I have everything there. Now, gee, when I look at it, I think some of these terms may cancel from one side to the other. I think, help me out here, guys, do the y squareds cancel?
Yes, and c squared.
C squareds cancel. I'm left with, and by the way, I thought the 2cy's might cancel, but if you move this over, do they cancel or not?
No, it's 4.
No, that's 4cy. So you're going to end up with, look at this, x squared is equal to 4cy. Oh, goodness.
No,
Now you said, Professor, what is that? That is another equation you place right here. We're talking about a parabola. X squared is equal to 4cy. That's what it looks like. Wow, sort of followed your professor, the distance formula, you squared both sides, and you did this, and PK was helping you over there. You guys agree with the derivation? I said the two distances equal to one another. And then after I set those two distances equal to one another, I had to square both sides and clean it up. We did it in green, so those terms canceled. I'm left with that. Whoa, and it all came from here. Yes or no? Boom. Now I say, Professor, why? I have enough to memorize as it is. What benefit, guys, can you tell me right now, what benefit would it be to have for a parabola this equation, and you guys are so accustomed to maybe these quadratics? What's the benefit here? That's not here.
It's more simple.
Yeah, well, it looks more simple here. But what's the big benefit here for a parabola compared to these quadratics? Why would they do that? X squared is equal to 4cy. What's that c representing? Back on the definition, what's that c representing? Is that c representing the location of the focus?
Is focus always on the same y axis?
No, it could shift. But right now, I'm going to just keep it very basic. Is that c representing the location of the focus?
Yes.
Back in middle school and with what we've done in this class with not knowing that, we didn't know that there was a focus. Did I ever mention focus before? I mentioned vertex. Now there's a focus on there. That's where this will be beneficial in case you go over to whatever a math course and they say, where's the focus? I'm not focused today. No, they're saying focus of a parabola. You need to have it in this form. You say, can I find it here, Professor? No. You find the vertex. Then they ask you, also, where's the focus now? So this thing has a focus, a directrix, and a vertex, and a curve. Is that true, guys? With all the derivation, I would ask you to derive this? No. But I had to, in closing down class, show you where it came from. Where on earth did that come from? When you look at it in the textbook, this is where it came from. You guys okay with this? Those two distances being equal? Now, did I give an example to try there or not?
Sketching this part.
Yes, let's just sketch one. And I'll show you what the others look like without a derivation. Try to start reviewing here. Mr. Park, that demonstration you did yesterday, I watched my students and they say, wow, Professor, if I need to take additional math courses, and I've started with MATH2, and he started with MATH2. Did you notice how he was involved? That's that little demonstration he did yesterday, pointing things out. Okay, tell me, which one did they ask you to do?
X squared plus 8.
X equals how much?
8y.
Beautiful. This is the only one we'll do. Up here, what you asked, these things could be shifted, horizontally shifted to the left, to the right, vertically shifted up and down. You say, what, Professor? The parabola itself. You've seen some parabolas in here being shifted. And that's going to shift the focus. That's going to shift the directrix. And maybe a little different. This one was a basic one. Now, before I show you a quick sketch, if I goes in student class to sketch this one for me, just quickly. But before you sketch it, does anyone think they know, after this discussion, where on earth is this thing called the focus located for the sketch of this parabola? Up here, hang on. Does anyone think they know the coordinates? Even right now, where are the coordinates of that focus? After you find the coordinates of the focus, you'll know where the directrix is. It should be the same distance on the other side. Yes?
0,
Oh, I heard 0,2. Hang on. He's telling me, Professor, that point that you did in your derivation, 0c, he says in this case it's 0,2. I don't see a 2 up here right now. How did he get 2? I see an 8.
Form.
Yeah, look at your standard form here. It says what? You got to put in this form here. You got to have 4 in there. So you got to be clever and say, wait now, if I will put in that standard form, I need to go back and rewrite that 8 as what? 4. 4 is in the form here. 4 times 2. Why? Now that fits what we just arrived perfectly. And 4 has to be placed in there. And is that the type of thinking you were doing? Beautiful. And therefore, this tells me, as he just told me, Professor, that's your C you're talking about. Now know the location of the focus. Now, grab this, guys, and quickly just close it down. With that said, here goes. Quick sketch. Let me place that focus on that first. 0,2. It's up here. Anyone identify for me where that directrix is located? Thank you. It should be on the other side. It's a line on the other side of what Arena read to us. It's over here or down here. at -2, here, same distance, except on the other side. And it looks like that, and I'll say, Gia, I say, well, where's the parabola, Gia? Is the parabola, does the parabola have a vertex at 0? Is this thing being shifted at all to the left or to the right, up or down? No. You've seen some advice that did shift. This one, no, it's just basic. So the graph's gonna look something like this. Vertex should be right here. And that's what we're looking at. I didn't draw mine to scale. If you draw them to scale, this distance is supposed to be the same as this distance here. Lined off a little bit. But that distance should be the same. By definition. You're done. Okay. Now what does this remind me of as I lead parabola? Reminds me of something of a flashlight where the bulb is inside here and the beam comes out. That's what sort of looks like the face of a flashlight, and the bulb is inside there on the focus. Yeah.
So what does it mean for the shape of it if the focus is like higher?
Oh, no, do it again. If what's higher?
If the focus,
Now, are you talking about maybe this number right here might be higher?
like, yeah, like it's.
Oh, beautiful. You said the number in the green? That's set.
No, the two.
Oh, yeah, got you. It could change to another number. He gave me a 2 here. I thought it was flat. You're saying we're not gonna sketch this, but she said, Professor, suppose we're 12. Now where's the focus located? 3. Because this 4 is set here, so this time she has to place a 3 there to get that 12, and now my focus will be up here at 3. And my directrix down here at -3. And everything would match up for me, and I get that parabola that I need. Yes?
I think it's negative, but.
Oh, beautiful, beautiful. Oh, what do you think happened if? I saw a student doing it already back there. If C were negative,
How can it square?
is that parabola will flip over? Is it gonna be upside down? Like we reflected across the x-axis? Is that negative going to force that to be upside down? Now the focus would be down here. And the directrix up here. So it could be upside down. Absolutely. If it were a negative. You flipped over. Yes?
Just a clarification question. The fixed point and directrix are in relation to the vertex, right? So
They are.
if the vertex is at 1, then the directrix would be down at 1 instead of -2.
Okay, all I can do about that vertex is, right here, that vertex had better be the same distance to the
Yeah.
focus as it is to the directrix.
Okay.
If it's not, that vertex is not on that parabola. So it's the same, in fact, every point on that green parabola had better, when I measure, I know this was off, when I measure from here to here, that had better be the same distance as from here to here. If not, that point's not on there. By definition. Whoa. We're doing a little grad school work here. Got anything else to ask me? Oh, well, wait, let me ask you this. I'm not gonna do it, but just think about it. Alina, I love that question you asked. Suppose it looked like this. X squared is equal to 12y. Gee, you just give me that. Suppose it looked like this. Now, tell me, hang on. You say, Professor, hold on to it. It's still gonna be written as 4 times 3. You said that's the form. Right? But I've written it a little differently. Someone tell me what might that make the parabola do this time if it's written not x squared but y squared equal to over here.
It's gonna open left or right.
There you go. It's gonna be a sideways parabola. We'll be doing this business. And you could actually plot points to make sure. You could form a little table and plot points. And then your focus would be inside here. It would be on the x-axis. And your directrix would be a vertical line this time on the other side like this. So it could open sideways to the left or to the right. The reason we don't do this one too much is why do we not do too much with a parabola opening sideways? I mean, it's out there and it exists, but why do we in math do not do too much with it? What's the problem?
It's not a function.
It's not a function. Wouldn't pass the vertical line test. Darn, I was like, gee, do this. I like the conversation, yes.
So, is the significance of the plate just like the direction in which like it's facing?
You mentioned direction, it's the key word. It is. That's the key word right there, direction.
So is there like a parabola that's like a cup or something?
Oh, look at that, she wants to tilt it. She wants to tilt, I know her by now. She wants to tilt the parabola. She's a professor. I can see the direction here on this screen when it's opening up. That's its direction, it's opening up. Then we discussed with Alina's help, it could open down. Then I changed it to make it look like this, and the student said, oh, it could open sideways. Right? So it depends how it looks. Now she, mathematician, she's a professor. Could I, oh boy, Gia, here's how I make this thing tilt. June, Mr. Park, my mathematicians, have you actually seen where a parabola had to be tilted some way on an axis?
Like to the, like 90 degrees?
Yeah, not just like the basic ones I have up here, open up, open down, sideways. Could it actually tilt on some axis? Something like that. Okay? Yeah, it's possible. It's possible. It could tilt. Are we gonna get into that, June? No. You always think outside the box. Okay, which I love. Guys, that's it. That's all I want to do with the parabola. I want to show you where it came from, the definition, what the shape looks like. You said, Professor, you want to have one of these on the test tomorrow? Goodness, you showed it to us today. Are you going to have one of these? If I do, it's going to be so basic. It's going to be so basic. Now, this one's done. The parabola's done. Now, the others, without much conversation, here goes, guys. And then we're finished with the course. It looks like this. This, got more this, at night, I'm gonna show you an example, sketch. That's right, x squared over 25 plus y squared over 4 is equal to 1. I may take that form there. In fact, better yet, you could say, Professor, could I write it to make it look more like that form over there? X squared over 5 squared plus y squared over 2 squared is equal to 1. Of course you could. That makes it look even more like the standard 40 minutes. All I want today is, I'd love to do more with it. I like to sketch it. Where is that oval shape? What? Just sketch it. Guys, for my example here, I think everyone in class can tell me when I get ready to sketch this. Can anyone tell me, either here or here, where are the x-intercepts located on this oval shaped ellipse that I'm looking for? And how do you find x-intercepts? You replace y by 0. That's what you want to do on the test tomorrow. If you find an x-intercept, we know that. If you do replace y by 0, this term drops out. It's gone. Now, what is x? If you actually solve it, is it plus or minus 5? X squared is equal to 25, so you got out here. You got out here. That Now, can someone tell me where are the y-intercepts? On this sketch I'm looking for, which should graph into an oval, and the process is for a y-intercept, and put this back in, is what? Replace x by 0 this time. To find the y-intercept. If you replace x by 0, this drops out. And then you solve that equation. And what's the solution to this? Plus and minus 2. You go up 2, down 2, connect. If the screen will hold it for me. And then graph it like something like that. And we'll accept that as my ellipse. There's my oval shape. Done. Mr. Park, in your higher math courses, did you guys ever encounter an ellipse that you had to do some calculus on, or do you remember?
I remember.
You did have an ellipse somewhere, and they asked you to do some calculus on the ellipse. So guys, that was a shape. Now, are there things going on with this ellipse that I'm not mentioning right now? Yeah, that's the definition. Like back on the parabola, I had a focus and a directrix, which you had never heard of. This thing has items. Right now, I just want you to know the shape. There's the shape. Now, before I leave it, could the shape be vertical rather than mine's more horizontal? Could it be vertical doing this business?
Yes.
Yes. As long as it retains that oval shape, it could be a vertical type
Depends on-
of an ellipse. Okay? Hey, what would happen, do you think?
It depends on the denominator.
It would probably depend upon, hang on now, someone tell me right quickly and we'll leave this. Here's what mine was to look like that. What might make it now, open vertically?
You can just change the denominator.
Yeah, put the 25 over here. And the 4 here.
Yeah. So the range will be.
Exactly. Now your x-intercept is what? Plus and minus 2, and your y-intercept is plus and minus 5. Now when you sketch it, yeah, you want to go vertical ellipse. Okay. Now he's already warned you. He says somewhere in your math courses, somewhere, if you guys take additional math courses, they may mention an ellipse, and that would be it. Now, that's all I expect. So tomorrow, if I do anything at all with conics, I'll say, sketch this. And they're really, Professor, yeah, just sketch it. I'm not asking anything else, just sketch it. And show me the x-intercept and the y-intercept. Gee, I know you're going to ask something. What are you going to ask?
If the values are equal to each other, do we assume it's a circle?
Whoa, tell the class again. That's exactly what I was going to ask before I close down. Tell the class.
If the values of A and B are equal to each other and the equation is the equation for an ellipse, do we assume it's a circle?
She says professor supposed to read. You hear what she said, guys? It graphs into a circle. So the ellipse turns into a circle. If those two denominators are the same, x-intercept is 5 and 5, y-intercept is 5 and 5, 5 to negative 5. It's a circle. Thank you so much. I thought she was going to ask also, Professor, what would this look like revolved around or around the x-axis maybe? I push this behind the board and start revolving it. Would it look more like a football shaped thing? If you imagine this being revolved around the x-axis, around and around and around, that shape will turn into like more of a solid, like a football shape. And they may ask you to calculate about the volume of that football. Have fun. Have fun. With it if you're asked. That one's done, guys. I'm finished with it. Last one. The strained one. What does a curve known as a hyperbola look like? Now see the form. So guys, here goes. I like to sketch x squared over 25. Hold on, Professor. Subtract y squared over 4 is equal to what? Take this form. You say, oh, you're using the same numbers you used for the ellipse, Professor. I am, for a reason. But what's the difference? I use a subtraction. That's a different curve altogether. It's called hyperbola. Now, tell me, in this class, as we close down the course, where are my x-intercepts on this so-called hyperbola curve that you've never seen, I doubt? Where are the x-intercepts located? And I'll get those out of the way
0.
now. Where are the x-intercepts? Plus or minus 5, isn't it? Replace y by 0, that term drops out. You say, oh, no problem, Professor. One out here. X-intercept out here. Now, I've been bragging on you guys. Can anyone tell me where the y-intercepts are?
Plus or minus 2.
Gotcha. I was waiting for that.
Only the plus 2.
Let's do it again.
Only the plus for positive 2.
Okay, tell me something to be aware of here. What might, go ahead. I would say as a student, professor, it's plus and minus 2. Those aren't the y-intercepts. If you try to find the y-intercepts, you're saying, professor, I'm supposed to replace x by 0 to find the y-intercept. That term would drop out. You will be left with this in your attempt to find the y-intercept. And you try to solve that. Trouble is, you'll finally end up with this. And trying to solve it. You're going to end up with square root of negative. You're into imaginary numbers. You can't have imaginary numbers on a grid. So there are none. You say, oh, we're finished then. How do you tell me, Professor, the hyperbola is just these 2 points? No. No. I wish. Don't go off to USC and ask you to grab a hyperbola, and you put that point and that point, and you smile and walk out.
Maybe it's a horizontal asymptote.
No, something else. Which I doubt you've seen, but it's definitely more than just those 2 points. Where's the curve, Professor? What does it look like, Professor? Are those 2's, 2 and negative 2, that I could not use? I'm going to place them on the grid. But I cannot use them as y-intercepts. I'm going to place them, though, for a reason. Up 2 and down 2. Step back and look at it.
We cannot touch it.
Yeah, exactly. There you go. So there must be an asymptote involved somehow.
Yeah, it goes on.
Guess what they do for us to get the sketch to look fairly good? They ask us to do this. It's a little procedure. They ask us to go ahead and connect those points and form like a rectangle. So they're saying, go ahead and do this. I'm trying to do it in a different color here. Connect and form, to close this down, form a rectangle that picks up those points Here goes. Guys, it looks like that. That's what are you going to do with that? That's the graph of the hyperbola? No, I'm not finished. So we'll go to USC and draw that. Then walk out and say, oh, I know what a hyperbola looks like. You know what you do? Yeah, I'm from SMC, it's a box. Oh, I'm not finishing on a box. There must be more for the curve there. Now, what they ask us to do, besides the rectangle, now draw in the diagonals. From corner to corner, and have them extend outside for a reason. And it looks like this. I'll have them extend outside. There's one diagonal. Draw the other one, from corner to corner. I can walk in right now and say, oh, Professor, you're doing elementary school stuff. From a box. Doing diagonals. Now you go to UCLA and put that, you say, oh, that's a hyperbola. No, we're not finished. Where's the curve? Must be be some curve. Does anyone have an idea? And I heard the word asymptote mentioned, and those diagonals are going to be acting as asymptotes. So where on earth is the curve for this unusual graph called a hyperbola? There's more to it than just this. Anyone have an idea?
So negative 5 and 5 are the.
These are the x-intercepts. I got to pick those up. Any idea? And you got to follow the diagonals. They're called asymptotes. And get your shape.
It's two parabolas.
June.
Is it too like tear shape, the orange water drops like that are side?
Oh, you mean like maybe over here? Let's get
Yeah,
this one.
that pick up the 5 that start at the origin and then pick up.
You're saying something like this. That follows those diagonals, follows those asymptotes, will not touch them, and picks up your x-intercept. There's one. Here's another branch on the other side. That does the same thing here, something like this. Extends forever. Guys, there is a shape of a hyperbola. It took that box of diagonals to get to it, but there's the shape. Jeez. That's what you had in mind, right? Got to step to the side here, look at that. Joseph, if Ramsey went crazy on you, which I'm not, this is the last day,